All right, today we're going to dive into a pretty wild idea called the MMU. It basically suggests that the very fabric of our universe might not be what we think it is. It asks us to imagine that spacetime isn't just empty. What if it's an actual physical material?
So let's just jump right in with a big question. What if the vacuum of space, the nothing between everything, isn't a void at all? What if it's more like a material, a hidden elastic structure that can actually stretch and twist and compress?
And okay, let's take that a step further. What if everything we think of as fundamental, light, mass, even gravity, aren't separate things? What if they're all just different ways that this one single deep medium responds to, well, everything? And that right there, that's the core idea of the MMU. It's basically a materials science view of spacetime. So the universe isn't some empty stage where things happen. It's more like a dynamic, structured solid.
Okay, so if spacetime is a material, the next logical question is, what's it made of? Let's talk about its fundamental building block.
This theory calls the building block the cell, and you can picture it as the absolute smallest possible unit of spacetime. It's this tiny, elastic structure with a really specific shape, kind of like two pyramids stuck together at their bases. And here's a really powerful way to think about it. The cell is for spacetime what an atom is for matter. It's the basic Lego brick. Just like all the stuff around us is built from atoms, the MMU says that the very fabric of space itself is built from these interconnected cells. And when you link these cells together, what do you get? A huge interconnected lattice. And here's the kicker. According to this model, that underlying geometric structure is what we perceive as the three dimensions of space. It's not empty, it is the space. But the real magic isn't just in the structure itself. It's what's happening inside each and every one of these cells. Think of it like spacetime's hidden internal engine. So, according to the MMU, an cell isn't just some static point in a grid. Nope, it has its own internal dynamics. There are three hidden ways it can move or deform. These are called its internal modes, and they basically define how the fabric of spacetime reacts to energy. All right, let's break these down. They're labeled W2, W3, and W4. The W2 mode is the electric one. Think of it as a change in the cell's density. Then you've got W3, which is a torsional or twisting response. The model links this to things like magnetism and quantum spin. And finally, W4 is a volumetric response, literally a change in the cell's size, and that's connected to mass and gravity. Now, here's the really crucial part. We can't actually see these W2, W3, and W4 movements directly. They're hidden from us. The physics we actually observe in our universe, that's just a projection of all this hidden motion onto an observable axis, which the model calls W1. It's like seeing shadows on a wall. The shadows are real, you can measure them, but the object casting them is in a deeper, hidden dimension. So what does all this mean? Well, if spacetime is made of these tiny dynamic things, it means we're living in what is basically an elastic universe. At its core, this theory treats every single cell like a tiny, complex system of springs. The source material says it perfectly. It behaves as a coupled internal elastic oscillator system. So a push in one direction, say an electric one, can cause a twist in another. I mean, that is pure material science right there. And you have to understand, this is a huge departure from standard physics. Usually, we start with fundamental particles and fields and build up. The MMU does the opposite. It starts with just one thing, the geometry of this cell and how it can deform. Everything else, particles, fields, forces, emerges from lat. And just like any real material has properties like, stiffness or flexibility, so does the cell. Its behavior is governed by these things the model calls stiffness constants. There's one for each of those hidden modes. You can really just think of them as the fundamental rules of the universe that decide exactly how much spacetime can bend and twist and compress. Okay, so how do we get from this hidden elastic geometry to the universe we actually live in and see every day? Well, that brings us to our final piece of the puzzle, getting physics from geometry. This really is the big question, isn't it? If all the real action is happening in these hidden modes, W2, W3, and W4, how on earth does that create the world we see, the world of planets and stars and us? Let's start with something we all think we understand, time.
In pretty much every other theory, time is just there. It's a fundamental coordinate. But in this model, where does it come from? And here's the mind-blowing part. In the MMU, time isn't fundamental at all. It's an emergent property. That steady, reliable tick-tock of a clock, it's actually just the observable projection, the shadow, if you will, of all that complex, hidden, elastic motion happening deep inside the Earth cells. The theory even gives us a formula for it. What we see as time, T, is actually a specific mix of those hidden electric, twisting, and volume-changing motions. It's almost like a recipe for how to cook up time itself from the basic geometry of space.
So, when you boil it all down, the whole theory is a pretty clear 4-step pipeline. First, you start with a simple shape, the Earth cell. Second, you define the rules for how it can move and stretch inside. Third, and this is the key, you project that hidden motion out into our observable reality. And fourth, boom, all of the physics we know and love just emerges.
So let's recap real quick. What is the MMU? It's a model that says space-time is a physical, elastic thing made of Earth cells. In this view, electricity is just a density change, magnetism is a twist, and gravity is a change in volume. And maybe most importantly, the reality we actually experience and measure is just a projection, a shadow, of the deep, hidden movements happening inside space itself.
So we'll leave you with this thought. We always use that phrase, the fabric of reality. The MMU asks us to take that idea literally and to wonder, what if that fabric isn't some soft, flowing cloth? What if it's actually a vast, vibrating, elastic crystal?